Okay, this is forces at angles, and just like vectors, we're going to split our forces into x's and y directions. So the first thing we're going to do is draw a free body diagram, and you'll notice it says a constant velocity, which means since the sled is going in the horizontal direction, there's no acceleration, and the sum of the forces in the x direction is 0. You also know the sled is probably not flying, so the sum of the forces in the y direction is 0. So they're pulling with 50 newtons of force at 42 degrees. The sled has a mass of 12. There's a normal force, but you also have friction. Okay, so in the x direction, we have this pull force, so 50 times the cosine of 42 minus friction equals 0. So friction equals 50 times the cosine of 42. And friction is equal to mu Fn equals 50 times the cosine of 42. But the problem is Fn is not equal to mg because you have this other force at an angle. So let's do the sum of the forces in the y direction. So 50 times the sine of 42 plus the normal force minus mg is equal to 0. So Fn is equal to mg minus 50 times the sine of 42. Plug in m and plug in g. And that will give you a value for Fn. Okay, so we're gonna put this in our calculator. And I get a normal force of 84.1 newtons. So you can see that the person pulling on the sled is helping the earth push up on the sled. So mu is going to be equal to 50 times the cosine of 42 divided by Fn, which is 84.1. And so mu is equal to 0.44.